In lesson 7, we're going to look at variation. There's 3 different types of variation that we're going to look at. The first type of variation is called direct variation. And basically what this means is when we say that y varies directly with some variable x, what we mean is that the relationship between these two variables is the same thing as saying y equals k times x, where this k is going to be some non-zero constant, which we call the constant of variation. Another way of saying this is to say that y is directly proportional to x. So we can say y varies directly with x, or we could say y is directly proportional to x, and that those two things mean exactly the same thing. So if you just look at these examples down here, just practice taking the verbal phrase and translating it into an algebraic equation. The first one here, y varies directly with x, so y equals k times x. Then we have s varies directly with the square of t, so that means s varies, so s equals directly means k times the square of t, which is t squared. And again, remember, another way of saying this is y is directly proportional. So y equals k times, in this case, the cube of z, so z to the third. Again, u is directly proportional to the square root of v, so u equals the k times the square root of v. And remember, in all 4 of these, the k is a constant of variation. So let's look at an example of how we would set this up and how would we use it. So for this first example, it says, suppose y varies directly with x. So the first thing you want to do is you want to translate that. So y varies, so y equals varies directly. So that means there's going to be some constant times x. So that's the first part. And then it says if y is 15 when x is 5, our goal here is to find y when x is 7. So basically we have 2 scenarios here. We have this first scenario, and then we're trying to figure out y in the second scenario when we know what x is. So what you're going to do first is you're going to take that first scenario when they give you what x and y is, and you're going to figure out the constant, and that constant is going to stay the same in both situation number 1 and situation number 2. So first I'm going to take number 1, and I'm going to plug into this equation. So this equation that we created will be used for this entire problem. So I have y is 15, so I'm going to plug in 15 equals k, and then x is 5. So now I'm going to solve this for k, so divide both sides by 5, so we get 3 equals k. What you're going to do now is you're going to set up your second situation, which is to find y when x is 7. So if I take and I plug in what I know into this equation, when x is 7, I can figure out y by using the same constant from the first situation here. So I'm going to go ahead and I'm going to plug this in. So now I can figure out y by just multiplying those, so I get y equals 21. So basically, we just went through the process of use the first scenario, plug in, figure out the constant. Once you know the constant, you're going to take that, use it again with this new variable information they give you when x is 7 to figure out y in this situation. So that constant can be used in all of the different situations because it's the constant. So let's look at some more examples. What we're going to do is we're going to look at the next type of variation, and we'll see an example that's basically very similar to this. It's just the initial setup is what's going to be different. So the next type of variation that we're looking at is called inverse variation. So basically when we say y varies inversely with the variable x, what we really mean is that the relationship between y and x is the same thing as y equals k divided by that x, or you can think of this as k times 1 over x. So basically the difference is here, the x is now going in the denominator instead of being multiplied. So you're basically multiplying by the reciprocal of x. So again, k is still called the constant of variation. And just like the other one, another way we can say this is using the word proportional And we can say, and so instead of saying y varies inversely with x, we can say that y is inversely proportional. So if you see varies inversely or inversely proportional, it means the same thing. So here's just, again, some more examples to help you translate from the verbal phrase to the algebraic equation. Inversely proportional means y equals k over x. Inverse or varies inversely, s equals the square of t, so it's s equals k over t squared. So basically this varies inversely means you put the k in and then you're dividing by this n part. So y is inversely proportional. Y equals k over x to the fourth. And y varies inversely. So varies inversely. So z varies inversely. So z equals k over the cube root of t. So those are just some scenarios. Let's look at an example. The volume of gas is inversely proportional, so there's my keywords there, to the pressure of the gas on its container. So basically, if I say volume is V and let's call pressure P, volume is inversely proportional to the pressure. So my constant K over the pressure. So now we're going to look at what scenarios we have. So this first scenario, if a pressure of 48 pounds per square inch corresponds to a volume of 50 cubic feet. So in that case, I have the pressure is 48 pounds and the volume is 50 cubic feet. We can take those two things. So situation number one means I can take the volume, plug it in, keep the K, and I can plug in the 48. And then if you look at the next situation, it's asking you what pressure is needed to produce a volume of 100. So it's asking you to find P, what pressure, when the volume equals 100. So that's going to be your situation number two. So basically, going back to situation number one, I'm going to figure out K, and then I'm going to use that to plug into situation number two. So in order to solve for K, this is where the rational equations come into play. So that's kind of how it's tying into this unit, solving a rational equation. So in order to do this, I put 50 over 1. I cross multiply is the easiest way to go about it. Remember, you could multiply both sides by the common denominator here of 48. So when I do this, I'm going to get K, or 1 times K, which is K. 50 times 48 is going to give me 2,400. So K is 2,400. Going to situation 2 means I'm going to take this information and I'm going to plug in. So I'm trying to find P when V equals 100. So now I can take this and I can plug it in for K, because remember that's the constant. So we have 2,400 over P, and we're trying to solve for P. So again, using this as a rational equation, solving it, put 100 over 1. The easiest way to do this is to cross multiply because you have a fraction equal to a fraction. So we have 100, P equals 2,400. Divide everything by 100. So we get P equals 24. So the units for this are 24 pounds. And that would be your answer. So there's one last type of variation which you're going to find is very similar. The problems are all the same. It's just the initial setup is going to be different. So that's the only difficult part, is just remembering which words go with what. So directly you multiply, inversely you divide. The last type is basically a combination. So it's called joint variation. So basically joint variation is when we have a variable and it's related to two or more other variables. So let's say we have y and it's related to two or more other variables. So what happens is it could be directly related to, let's say, x, but inversely related to z. So let's look at some examples of how you would set this up. So for this first one, we just we just have that y is varies jointly with x and z. So it's varying jointly with both of these. So that means that this is a direct variation in the sense that it's going to be y is directly or varies directly with x and varies directly with z. So y equals some constant times both of those. For this one, we have z varies jointly. So again, kind of think of it as a direct variation here. You're just multiplying by both of these. Where this next one, we have two different scenarios. It's varying directly with t, or it's directly proportional. Remember, varies directly proportional mean the same thing. So it's varying directly with t, so it's going to be your constant times t, but then it's inversely proportional or varying inversely with p, which means you take that constant and you're dividing by the variable. So you're basically doing both things here. So you have your direct variation and then you have your inverse variation. So you have the direct and you have the inverse happening. So that's why we call it varying jointly. And then the last example here, it varies jointly with M1 and M2. So that's up top. That's like a direct variation. All three things are being multiplied, or you're multiplying the two variables by the constant. And then inversely with the square. So that's why r squared is on the bottom. So let's look at one example of how to set up a problem with this. So we start with our scenario. Suppose y varies jointly with x and the square of z. So y varies jointly with these two variables. So since it doesn't say anything about inversely proportional or varies inversely, this means that there's going to be some constant times each of these. So times x times z squared. So then we have our scenarios. Well, when x is 5, z is 3, and y is 180. So that's going to allow us to find k if we plug in. And then the other scenario is we want to find y when we have these other two. So we're going to start with scenario number 1. We're going to take and we're going to figure out k. Once we know k, we can plug it in to figure out this missing variable. So notice here that they had to give us 3, since we have 3 variables, they have to give us 3 variables in the first one. They have to give us 3 numbers for the variables, and then in the second situation, they have to give us 2 out of the 3. Otherwise, you wouldn't be able to solve the problem. So we're going to go ahead and we're going to plug in. So we have 180 in for y. Then we have k is what we're trying to find. X is going to be 5 and z is 3. Then we're going to go ahead and we're going to solve this. So we have k times 5 times 9. So 180 equals 45k. Divide both sides by 45. We get 4. So that's our constant. Now we go to our second situation here, and we're trying to figure out y. So it's going to be y equals the constant times this new x value that they give us, which is 2, and the new z value, which is 4. And we're going to take and we're going to plug in our constant because it remains the same. And then we're going to go ahead and we're just going to solve this. So we have, if I combine these, I get 8 times 16. So y equals 8 times 16. We get 128. And that's it. So it's kind of just taking another look at rational equations and seeing another type of problem that you can do using rational equations.